Pokémon has a lot of puzzles, but the ice puzzles are different, because once you start moving, you don't get to stop when you want. What's weird is, these puzzles are actually pretty fair, but if you try to solve them in real time, even simple ones can feel brutal. The problem is in the way you are thinking about these puzzles. Ice puzzles punish improvisation, but the moment you stop moving, the puzzle stops being about reflexes and becomes about planning. So let's stop playing the puzzle and start modeling it. We have wall tiles, normal tiles and ice tiles, but not every tile matters. The only tiles that really matter are the ones where the game lets you make a decision. Let's call these stoppable tiles decision points. If you slide over an ice tile, you don't choose anything there. It can simply be ignored. But if you hit a wall or a normal tile, you will stop. From such a decision point, you just choose a direction. Each input, up, down, left, right, collapses into exactly one outcome. That's an edge. These edges represent one move. In order to reach the goal, you need a sequence of such moves, resulting in a path from the start to the goal. Here's the dangerous part. Some slides are directional. You might be able to go from A to B, but not from B back to A. At least not directly. In graph terms, these are directed edges. Pokémon puzzle designers know this. That's why you can never get permanently stuck. Every valid puzzle guarantees a path back to a useful decision point. You might waste time, but the puzzle never deadlocks you. So far, you were able to see the entire graph. You could plan the solution first, then execute it. Even if you mess up, the graph is forgiving. There's always a reasonably simple path back. Planning and execution are decoupled. So why do some ice puzzles feel brutal, even though the rules never change? Some puzzles are simply too large, you can't see the graph. Decision points are off screen, you are forced to explore just to learn the graph. Mistakes still aren't fatal, but they cost more time. Emerald Kaizo takes it to the next level. The graph is even larger, and fog makes it much more difficult to find critical decision points. The puzzle isn't harder because the structure is different. It's harder because you don't get the graph for free anymore. You have to explore and memorize it. And now, this. Same idea, but with one extra tile type. Ledges. From one direction, it's an edge. From another, it's a wall. From another, it's irreversible. That means we add a lot of directed edges to the graph. And here's where things get brutal. These puzzles are entangled. One wrong decision in the second one doesn't just cost time. The graph is no longer strongly connected. Some choices permanently remove paths. The goal isn't reachable anymore. All you can do is to go back, resetting your progress. You have to do the first puzzle again. But will you remember your mistakes? This explains something every player feels but rarely articulates. In the Shoal cave puzzles it's mostly plan first, execute second. But in the additional Emerald Kaizo puzzles, you're planning while executing. Under uncertainty, with memory pressure and irreversible consequences. And to be clear, this isn't bad design. It's intentional design for a different audience. Vanilla puzzles teach you how to think. Kaizo puzzles test whether you can execute. So how do people actually solve ice puzzles? Not by sliding carefully, and not by reacting in real time. Definitely not by spamming random inputs. Good players switch between two completely different modes. If the puzzle is fully visible, we can start solving it immediately. The best strategy is surprisingly backwards. Instead of starting here, you start here. You ask a very simple question. Which decision points could possibly land me here? Those tiles become candidates. From each of them, you ask the same question again. If one of those paths reaches the start, you're done. If it loops or hits a dead end, you would backtrack and select another candidate. At this point, movement doesn't matter anymore. You're not playing the puzzle. You're solving a graph problem using an algorithm. But what if the puzzle isn't fully visible? That's where ice puzzles suddenly feel hard, and here's why. In large puzzles, especially with fog, you're not solving yet. You're still building the graph. The goal is information. You look for decision points, tiles where you can stop. Especially pivot points, normal tiles surrounded by ice. Reaching one of these reveals new parts of the puzzle. Plus, you memorize the paths that lead there. Even a failed attempt isn't wasted. It adds structure to your mental map. Once the puzzle is mostly known, something interesting happens. You stop experimenting. You switch modes from exploration to exploitation. That's when ice puzzles suddenly feel easy. You're no longer thinking in real time. You already solved parts of it. You can ignore movement, combine partial solutions, and reason about reachability. You're just executing the plan. So, ice puzzles aren't really about sliding. They are about identifying decision points and planning paths between them. Once you actually see the graph, the puzzle stops fighting you. In future videos, we will build a solver that automatically finds optimal solution paths and engineer a generator that automatically creates fair and interesting ice puzzles for us. That's where this really turns into computer science.